The Earth may seem massive and awe-inspiring, but in the grand scale of the cosmos, it's nothing more than a speck, a minuscule dot floating in an endless sea of stars, planets and galaxies. Humanity has always been captivated by the mysteries of the universe, and with the advent of modern technology, we've begun to uncover some of its secrets. Rockets and satellites have been our tools in this grand quest for knowledge, sending data from the far reaches of space back to Earth, giving us insights into the unknown. Our curiosity pushes us ever further, with each discovery sparking new questions and inspiring even greater achievements. The hunger to understand the universe, to explore its vastness and complexity, seems insatiable. How do we, as a species, begin to unravel the mysteries of the cosmos? A significant part of the answer lies with the voyages we've undertaken into space, missions that have provided a wealth of information to process and analyze, shedding light on corners of the universe that were previously beyond our reach. Yet, despite our advances, space exploration hasn't always been smooth sailing. For the past several months, communication with one of our most famous spacecraft, Voyager, had been lost. A radio silence that stretched on for months had scientists on edge, wondering if one of our most ambitious missions had met a sudden and silent end. Then, out of the blue, Voyager re-established contact, revealing that not only was it still functioning, but it had made an unexpected discovery. This moment of reconnection was a reminder of just how much we stand to learn from the data being sent back from the far reaches of space. But before delving into the significance of this latest discovery, it's important to understand the Voyager mission as a whole, how it all began, and what it has achieved in its more than 4 decades of exploration. In the late 1970s, the Voyager mission was launched with the goal of exploring the outer planets of our solar system. On August 20, 1977, Voyager 2 took off into space, its mission to journey through the vast expanse beyond our planet and provide unprecedented data on the giant gas planets, moons, and other celestial bodies. Shortly after Voyager 2 began its mission, NASA made history by capturing a picture of both the Moon and Earth together in one frame, an iconic image that symbolized the beginning of humanity's quest to explore the unknown beyond our planet. The primary mission of the Voyager probes was to study the outer planets, Jupiter, Saturn, Uranus, and Neptune, yet the spacecraft also carried with it the potential to send back information about stars, galaxies, and the interstellar environment. Equipped with highly sophisticated instruments, Voyager was capable of measuring and monitoring its surroundings as it traveled through space, collecting data on magnetic fields, particle densities, radiation levels, and even the properties of interstellar clouds. Communication with Earth was key to the success of the mission, and Voyager was equipped with a unique communication system designed to send vast amounts of data back to Earth as it moved further into the solar system and beyond. This technology was essential in understanding what Voyager was encountering as it passed by planets, moons, and other astronomical objects. Just a few weeks after the launch of Voyager 2, on September 18, 1977, Voyager 1 followed closely behind. With both spacecraft on their way, a mission of historic significance was officially underway. Together, Voyager 1 and Voyager 2 embarked on a journey that would take them to the farthest reaches of our solar system, providing us with unprecedented insights into the nature of the universe. The timing of the mission was no accident. Although many people assume that the planets in our solar system orbit in a perfect circular pattern, this isn't true. The orbits are irregular and elliptical, meaning there are rare windows when the planets align in such a way that makes space travel more efficient. August and September of 1977 marked one of those windows, where the planets were positioned in a way that allowed the Voyager probes to complete their mission without having to take significant detours. The alignment of planets was a fortunate coincidence, but it made the mission feasible and set it up for success. The probes themselves cost an astounding $865 million, a considerable investment at the time, but one that would prove to be worth every penny. Within just a year of launch, both Voyager spacecraft had already made it all the way to Jupiter. The results were nothing short of astonishing. Voyager 1 and 2 sent back more than 4,000 images of the gas giant, revealing 2 new moons and even a previously undiscovered ring around the planet. The discoveries continued to pour in, and the mission quickly exceeded everyone's expectations. What had started as a quest to better understand our solar system was rapidly transforming into something much larger. Each new discovery opened up more questions, more avenues of inquiry. It seemed as though the possibilities were endless, and humanity was on the cusp of a golden age of space exploration. One of the most memorable moments early in the mission came when Voyager 1 captured a breathtaking image of Earth from a distance of 11.7 million kilometers. This was the first time a photograph of both Earth and its moon had been taken from such a distance. Seeing our planet as a tiny speck next to its companion gave humanity a new perspective on our place in the universe. It reminded us of how small and fragile our world is, a solitary dot in the vast emptiness of space. Yet, despite the vastness, this small spacecraft made of wires, metal, and ingenuity was hurtling through space, capable of taking such extraordinary photos from millions of kilometers away. As the mission continued, Voyager 1 sent back more awe-inspiring data. In March of 1979, just 2 years into its journey, Voyager 1 took its first close-up pictures of Jupiter from a distance of 57.6 million kilometers. The spacecraft captured stunning images that gave humanity its first detailed look at the largest planet in our solar system. But that wasn't the only surprise. By analyzing the pictures, scientists made a groundbreaking discovery: volcanic activity on Jupiter's moon, Io. This was the first time volcanism had been observed beyond Earth, expanding our understanding of what might be possible in the solar system. However, the excitement of these discoveries was dampened by an alarming setback. NASA lost contact with Voyager 1 for a period of time. The loss of communication was a nerve-wracking experience for the engineers and scientists who had invested so much time and energy into the mission. There were real fears that all might be lost, that the spacecraft had suffered a catastrophic failure. The mission was, after all, breaking new ground, and there was no precedent for what to do in this situation. Thankfully, after days of intense effort, contact was re-established, and the mission resumed. It was a stark reminder of the challenges of space exploration, and the fragility of the technology that makes it all possible. Voyager 1 continued its exploration, making another significant flyby in November of 1980 when it passed by Titan, Saturn's largest moon. The data sent back to Earth revealed that Titan was even more mysterious than scientists had imagined. Its atmosphere was 10 times thicker than Earth's and rich in nitrogen and organic compounds, suggesting that the conditions on Titan might one day support life. This discovery opened up an entirely new field of inquiry about the possibility of life existing elsewhere in the solar system. The surprises didn't stop there. Voyager 1's flyby of Ganymede, the largest moon in the solar system, revealed an icy, cratered surface, and once again, the spacecraft defied expectations. Prior to the flyby, scientists had only rough estimates of Ganymede's size. But Voyager 1 showed that Ganymede was larger than previously thought, even bigger than Titan, and had unique geological features, such as grooves and ridges, that hinted at dynamic internal processes. The data from this encounter provided invaluable insights into the geology and composition of icy moons, which are now considered some of the most intriguing bodies in the solar system for future exploration. By the early 1980s, it was clear that the Voyager mission had far exceeded its original goals. The spacecraft were not only providing unprecedented views of the outer planets and their moons but also laying the groundwork for future exploration. And so, NASA made the bold decision to extend the mission, sending both Voyager 1 and 2 beyond the bounds of our solar system into interstellar space. This would mark humanity's first foray into truly uncharted territory. Voyager 1 reached interstellar space in August of 2012, becoming the first human-made object to leave the influence of our Sun and enter the space between stars. This was a monumental achievement, and the data that Voyager 1 has been sending back from this region is giving scientists their first direct measurements of the interstellar medium, the vast space between stars. Voyager 2 followed its companion into interstellar space in November of 2018, continuing the legacy of discovery that began more than 4 decades earlier. However, despite the mission's success, there have been moments of uncertainty. In March of 2020, NASA made the difficult decision to temporarily halt communication with Voyager 2 as the Deep Space Station 43 in Australia, the only antenna capable of sending commands to the spacecraft, underwent crucial renovations. For 11 months, there was no contact with Voyager 2, leaving scientists anxious as the spacecraft, now more than 18.6 billion kilometers from Earth, continued its lonely journey into the unknown. The Voyager mission is far from over. Both spacecraft are expected to continue sending back data until at least 2025, providing us with even more insights into the nature of the universe. From the outer planets to interstellar space, the Voyager probes have revolutionized our understanding of the cosmos. Their legacy will endure as one of the greatest achievements in the history of human exploration. Each new discovery reminds us of the vastness of the universe, and the limitless potential of